This is how to draw a motion diagram for my second example. I've got a car going across the screen from right to left, and I'll make several images every tick of time that passes. So now I can see the motion as it goes across the screen. Time to pick the motion diagram, put in the dots. Notice that where I pause, I just make the dots climb up the screen and then continue on from the top, going in my direction. Then I'll connect them all with arrows. There won't be any arrows connecting the vertical column of dots because there's no motion, so there's no arrows to draw. Now if I look at this, I can also determine the acceleration. I'll take the initial velocity, like the very first one, and then I'll compare that to the next velocity afterwards, which I'll call the final velocity. And the difference between these two, that change in velocity, that's the acceleration. And you can see that I had to make that final velocity shorter, or in order to make it shorter, I had to have an acceleration go the opposite direction. So that's a positive acceleration because it goes to the right. We'll consider that to be positive. In the previous example, it was also a positive acceleration, but the car went the other direction. So in this case, I've got a very negative velocity, and the change in velocity is positive, which gives me a less negative velocity. So this negative velocity is getting smaller and smaller. The car is coming to a rest. In terms of the sections, I can divide this up into sections. I can see that the first section here, that's where it's decelerating, or in this case, it would be a positive acceleration actually. Positive acceleration. And then I've got a section where it's paused. That's a constant velocity. It's not interesting. It's just a constant velocity of 0. In the final section here, it's moving with a non-zero constant velocity. So the next task, I can describe this in words into 3 sections. I would have it say something like, the car experienced a positive acceleration as it slowed down for 4 ticks of time while moving in a negative direction. So I've got the direction, I've got if it's accelerating or moving at a constant velocity, if it's positive or negative, and I've got a little mention about the time. And then it paused for 4 ticks of time, nothing there. Finally, it moved in a negative direction at a constant velocity for 3 ticks of time. So I've got positive, negative, I've got the direction, I've got something about the velocity, and a little mention about the time. So there's a lot to this description to get it all in there. Next step, a graph. Here's going to be a velocity versus time graph. Now at first it's a positive acceleration, so on a velocity versus time graph, acceleration is the slope, so I would make a positive slope. Now because it starts off initially with a very big negative velocity, I'll start down here with some kind of negative velocity. And it's an upward sloping line, which means it's a positive acceleration. Positive slope, positive acceleration. Then it pauses. So where it pauses, there's just a horizontal line where v equals 0, and there's no motion there because that's where the velocity is equal to 0. At that point it begins to move again, but this time when it moves, it's moving at a constant velocity, so it's a straight horizontal line, and it's less negative than the starting velocity. And that's because if I look at the two velocities, here's the beginning velocity and here's the velocity later, and you can see that the beginning velocity is much bigger than the later velocity. So in terms of my graph, the beginning velocity is farther away from 0 than the velocity later. In other words, the blue line starts farther away from 0 than the red line.